Hello guys, we'll be solving subarray sum equals k. Basically, we need to find subarrays that have the sum k. This has actually three approaches. We will be talking about all three of them, though only be implementing the linear time solution. This is the n square, which should not be passing by the way, because this is 2 into 10 to the power 4, which is slightly larger than 1 second, but somehow it does pass. Uh, but yeah, let's get into it. So basically, just to clarify, this can have negative numbers, or else we could use unordered set, and I'll explain why. Uh, I'll just paste this. Yeah. Now, what we want to do is basically what this approach is basically when, like, let's say this is an array 1, 5, 6, 2, 3, 1, and k is equal to 6, and the answer should be, by the way, theoretically, these two, this, and these. So three, right? Anyways, the brute force would be to basically have three pointers, I, J, and another K, which would basically range from here to here. And this J keeps on sliding, then I moves. So that would be the n square, n cube solution. And then the running some idea for every fixed I is the n square solution, which is this one. Now, for optimization, I think we need to understand how we can think in the idea, right? Okay, so okay, so what we can do is we can basically manage a prefix sum, and we will do this because, well, let's say we want to find any point, and we want to check if it is divisible, if it is equal to 6. So obviously it needs to, this value or these certain values need to equal to some point that is also not here, right? Like for 23 plus something to be valid, minus let's say y to be 6, we need to find if, like, let's say these two are consecutive, so we need to find if these exist somewhere before us, and that would be the answer, right? So yeah, that would be the unordered map idea. We will store the sum that we see, prefix sum, which is very important for interviews. So let's say we have a prefix map. This is the prefix map, and this is sum. Okay, now let's start from here. We will look for, at every position we will look for some minus k, because, well, I just explained why. Basically, for any point to be equal to 6, it needs to find something that is equal to 1 minus 6, or some minus k, basically, right? So we'll initially put 0. I'll explain this later on. So for 0 we have 1. Okay, okay, right. Now we start from here, running sum. Sum for I is equal to 0 is 1. And now we'll search if there is 1 minus 5 available. Is there 1 minus 5 available in map? No, we don't. So we'll keep on moving. And this will be the counter, by the way. This is the counter. Counter is 0 to find the subarrays. Now we go to this. So 1 plus 5. This becomes 6. Now we search for 6 minus 6. Okay. So initially the idea is we set this to be 0 because let's say there is something like 0, 1, 5, and same k is equal to 6. So we know these three would also form 6 and these would also form 6. So initially we always know that there could be many number of zeros here, and these would always equal to starting first subarray sum, because they won't add anything except 0, and 0 adds nothing. So that's the basic idea. Okay, so now we will say 1 plus 5 is 6. Is sum minus k 0 available? Yes. So this becomes 1. Okay, now let's go here. 6 plus 6. This is 12. By the way, okay, so we also need to insert this at every position. Sorry. So we'll also add this. 6 counter 1. This is basically the of this frequency of this. Okay, and this is important because for negative values, for positive values we could use set because every positive value would in fact be adding some and not decreasing, so we won't be reusing this. But for zeros and specifically zeros and negative values, we need to use an order map. Okay, so this is 12. 12 minus 6. Okay, so 12 minus 6 is 6, and we already have it in map. So we'll just make this to be 2, and we'll set the counter to 2. We've already found two prefixes with 2 as some prefix subarrays. Okay, now let's go to this. This is 12, and 12 plus 2 is 14. We'll search for 14 minus 6 in map. There's no 14 minus 6, but we'll add it now. So we have 14 now in map. So 14 basically is added to the map. Okay, this should be, by the way, I actually made a mistake. This should still be 1. It should actually be 1. I'll just change it. This should be 14 1, and this one should be 12 1. We're not adding the difference, we are adding the sum itself. So this is 12 1. Okay, now we come here. So 12 plus 2 is 14, and we already found 14, did not find and added. So now this is 3. This becomes 17. So 17, and we search for 17 minus 6. It's not available, but we'll add it. So this becomes 17 1. Okay, now we'll add one more plus 1. Now we'll get 18, and we'll search for 18 minus 6, which is 12, which is available in the map, by the way. So we'll increase the counter to be equal to this frequency, which is 1. So this becomes 3. And then we'll also add 18 to our map. Now we're done with the array iteration. So we'll just exit and return this counter as the answer, which is 3. These 3, right? This and these. Now let's try to understand with these constraints specifically negative values, zeros, and well, these values. So I'll just make another example. Let's say 0, 0, 5, 1, 6, 660, okay, minus 660, 672. Okay, that's it. Okay, now you'll understand why we need to add 0 initially. Because the thing is, we can always have some as 0 without taking anything, and that would initially always give us the first frequency counter. So whenever eventually we find our first subarray, like let's say the target here was 7 for a second. So we'd actually see 7 minus 7 is present, which is 0, and it already has a count of 1. Okay, I hope this makes sense. But let's start. Yeah. So k is equal to, let's say, 6. Okay. So now we have map as 0, 1. Okay. This is the map, and this is the counter value. And well, we can maintain sum here. Sum is equal to 0 initially. Now we'll add this. So when we start here, okay, we find another one. So 0 plus 0. Okay, we search for 0 minus 6, which is not available in the map, but we do find this frequency, and we'll add this. So we have this. Okay, now we go over here, another 0. Okay, another 0, and this will become, I'll just actually, okay, this becomes 3. Now we go here. Okay, 5. This becomes 5 finally. We search for 5 minus 6, which is not available in the map, which is minus 1 basically, not available in the map. But I'll add the 5. 5 is available now. Okay, 5. Now we come over to this. 5 plus 1 is 6. Now we search for 6 minus 6. Is it available in the map? Yes, it is. How many times? 3. So basically the 3 would represent something like this. This would be one of them, this would be one of them, and this would be one of them. If that makes sense. 3, right? So we make C is equal to 0 to directly 3. The frequency of, well, sum minus k. And then we add the sum to the hash map. So this becomes 6, 1. Okay. Now let's come over to the next one. This is 12. We find 6 plus 6 is equal to 12. Now we ask again ourselves, is sum minus k available? 12 minus 6 is available in the hash map and its count is 1. So we'll add that and we'll add this to the hash map as well, the sum. 12, 1, and this becomes 4. Okay. Now I think now things would start making sense for why we take unordered map and not a set. Okay, so now this is minus 660. So 12 minus 660 is 648, right? I think 648, minus 648. Let's say this is minus 648. Okay, we search for the hash map to have this value. It doesn't, so we'll not do anything. And then we'll just add minus 648 as one frequency. Okay, now we come over to 672. Now, when we come over to 672, we'll basically, okay, this should be 666 to just make it more sense, okay? Just make it 666. So we'll have another answer, okay? So let's add 666 here. So 666, yeah, okay. So 666, okay, 666 is basically, I think I'm doing something wrong. Wait, let me just check. Minus 660 for some reason. Why am I not able to subtract this? Oh, okay. Actually, I forgot to add this. Okay. So this would be basically we have a frequency of 12. So we will just get another value here, 5. And this would be our subarray because it's present here, right? So that would be our answer and we'll return 5. So the 5 are 1 are these, 1 are these, 1 are these, this one, and this one, right? So yeah, that would be the answer. Okay, guys. I'll actually just code it up here just to clarify. Okay, so just see this int counter is equal to 0 and mapper, let's make a map. Frequency and frequency of 0 should be 1 initially because we need to count the first one correctly. Okay, now let's start iterating over this. Okay, we also need to make a sum in sum equal to 0 for so then just plus. Okay, n is, let's define n. Okay, sum plus equal to so I. So now the difference is this is equal to, the difference will be sum minus k, which we need to find. So we will do this if map.find, so frequency dot find difference is not equal to, basically is present in the map, then we add this to the answer itself. So it's equal to frequency of difference. Okay, and then we will add the sum to the hash map itself. So this would be basically frequency of uh, sum plus plus, and now we just, once we're done, we get the counter. Okay. Okay, so this is the linear solution. I don't think it's easy to come up with by yourself. You can actually start thinking in other ways. There are similar problems which gave me the idea, by the way. There is some subarray sum divisible by k or something along the lines like that, which is also pretty similar to this. So I recommend you to solve that too after this, if possible. It uses the same idea basically, where we need to find any subarray which is divisible by k. So let's submit this. Okay, so it works. Okay, thank you guys.